Hello, everybody, and welcome to this poster session, Confidential Computing with Always Encrypted using Enclaves. My name is Peter. I'm a program manager in the data platform security team at Microsoft, and that's the team that manages all the security features inside Azure SQL and SQL Server. And I'm the program manager for two features. One is called Ledger, where we're not going to talk about today, and the other one is, of course, Always Encrypted. Let's have a quick look at the agenda for today. So first of all, I'm going to explain what was Microsoft motivation to invest in this functionality, Always Encrypted, and then we're really going to jump into detail on how everything actually works, and we're going to end with a demo so that you can see how the functionality works inside Azure SQL. So what was our motivation? We wanted to enable our customers to confidentially store their most sensitive data in the cloud. But we also wanted that the customers were still in control of their data, right? So we wanted to protect sensitive data from high privileged users, but unauthorized users. And to give you an example, in my previous life, I was a database consultant. So when I arrived at my customers, I typically had enough permissions to run select queries. So I could literally see everything that was inside these tables and these databases. And sometimes, these tables, they contain sensitive information and you don't want to expose that to everybody. So we came up with a solution for that, or that was our motivation, and that's why we built Always Encrypted. We also include this to support the zero trust initiatives, which means that an attacker, when they get into the database, they will never ever have access to the data encryption keys because we never store them inside the database. We just store the metadata to the location of the encryption keys, but all will become more clear when we jump into the details. We started our journey towards confidential computing in SQL Server 2016. This version is still available in the later versions of SQL Server. It's available in Azure SQL and in Cosmos DB. How does it work, Always Encrypted? Everything inside this box is the application side and is considered as trusted. Everything outside the box, like ciphertext and the database engine, they're considered as non-trusted. So it's really a client-side encryption technology. Now, what happens if your application requests information to the database engine? So we're requesting this in plain text, but then the SQL client driver is going to convert that plain text into ciphertext. And then, so the query is then sent over the network in ciphertext to the database engine. The database engine is going to fetch the information that the application requests and is going to send it back in ciphertext, again, over the wire. And then the SQL client driver is then going to decrypt the information and is going to show it to you in plain text on the screen. So again, it's really the client driver that transparently encrypts and decrypts the parameters of your query. So nothing is stored inside the database engine. Now, with this first version, we had confidential computing, but our customers, they were quite limited in functionality. So, for example, you couldn't use an encrypted column in a where clause, except if you would use equality, but sometimes you would like to use larger than, smaller than. You couldn't use joins, you couldn't use group by. So we had encryption, but we were quite limited in functionality. So we came up with a newer version of Always Encrypted, which is Always Encrypted with Secure Enclaves. That was released in SQL Server 2019 and 2022, and we also have it available in Azure SQL Database. Now, the principle is exactly the same, so we still have our application, which is the trusted side, but now the database engine can use what we call a secure enclave. So when processing SQL queries, the database engine delegates computations on encrypted data to a secure enclave. In that enclave, you should see it as really a black box where nobody has access to, not the operating system, not DBA. So literally nobody has access to that secure enclave. Now, by leveraging that secure enclave, Always Encrypted can now support what we call rich confidential queries. So you can now use pattern matching, like using like in a where clause on an encrypted column. You can use range queries, larger than, smaller than. You can order by, you can even create an index on an encrypted column. So you get much, much more flexibility here. And on top of that, an extra advantage of using these enclaves is in-place encryption. So when you start an initial encryption on a column, in the first version, we had to extract all that data outside of the table, do the encryption on the application side, and then push it back in the database. By using these enclaves, this is not necessary anymore. We can just use the enclave so the data can stay inside the database, which makes it much faster and much more secure. So as you can see, lots of advantages by using these enclaves. Now, what is an enclave? I already explained it. So it's an isolated region of memory. It's really a trusted environment where you can execute calculations. So it means that the data that is stored inside that enclave cannot be accessed from outside the enclave. So it's really secure. Now, how can we make this enclave secure? And we have two different options here. So you can use hardware, and that's also what we're using. So we're using the Intel SGX or Intel Software Guarded extension. That's really a physical CPU that we're using inside our servers to guarantee the isolation of the enclave. The other option that we have is hypervisor or software enclave, which is what we call virtualization-based security or VBS enclaves. That's a setting that is available in Windows Server 2019 and higher, and Windows 10 and higher. Let's make a comparison between the two. So we both support secure enclave, SGX and VBS in Azure SQL Database. Now, where's the difference between the two? First of all, if you want to use SGX enclave, you need to specify a specific type of database, which is what we call the DC series. And when you configure a DC series under the covers, we are going to configure a virtual machine that is actually going to use that physical CPU. For VBS enclaves, there's no hardware dependency. You just need to switch it on, let's say, and then you can start using VBS enclaves. The difference is that for SGX, you are limited to 40 physical vCores, while with VBS enclaves, there is no limitation. You are also a bit limited in the number of regions where we have DC series available. So it's East and West US, North and West Europe, Canada, Central, UK South, and Southeast Asia. Now, where's the difference between the two, right? What should you choose? Should you go for SGX or should you go for VBS enclaves? And it all depends on from who you want to protect your data, right? Because VBS enclaves do not protect you from attacks from the host OS. Perhaps bluntly said, but if you do not trust Microsoft, then don't use VBS enclaves, but go for SGX enclave. But if your policy or your company policy is like, oh, hey, we just need to protect data from malicious insiders like DBAs or like me, a database consultant, then for sure VBS enclaves will be sufficient. Again, as long as you don't have access to the encryption keys, you won't be able to see the data, right? So this is, the difference between the two. Now, let's jump into a demo so that you can see how Always Encrypted actually works. All right, so this is a simple web application. And as you can see, it is used by an HR department. And as you can see, it contains lots of sensitive information. You have the social security number, first name, last name, and the salary of all the employees in a company called Contoso HR. So quite sensitive information. Let me jump quickly to the portal here, because what I wanted to show to you is my demo setup as well. So I have the database here that contains that same information. I'll come back to that immediately. We have the web application that you've just seen. And I also have a key vault. The key vault is used to store in my encryption keys. So if I go here to the encryption key, you can see I'm going to use a column master key. So it's the column master key that is going to be used to encrypt the columns. So my application has access to this key. My account, my login doesn't have access to this key. And you will see the difference immediately. All right. So I go to my management studio here, and if I run this particular query, so this is fetching all the information from the table, you can see here that my account can actually see that sensitive information, Social Security number and salary. I don't want to expose that for everybody. I only want to expose that when you're using the application. So people that are trusted and that use this application can see that information. Me, as a DBA, I shouldn't see this, right? Okay, so let's encrypt that column or both of the columns. What do? I go to my table here and I select encrypt columns. This is just an introduction of the wizard. I'm going to select Social Security number and salary. And I'm going to choose randomized as my encryption type. Randomized means that in my columns, I have the same value, then the encrypted value will be different. So that is stronger than the other encryption type, which is called deterministic. The encryption keys, I've already pre-configured those. Just click next. I don't need to configure anything anymore on the keys. Forget about attestation. I'm just going to proceed and finish now. This is a summary of what I'm going to do, and there we go. So now this always encrypted wizard is performing encryption operations and is going to do that initial encryption on both Social Security number and salary. This just takes a couple of seconds to complete. All right, so that's done and everything is passed. So it means that the encryption was successful. Now, when I run the same query again as my account, my login, you will now see the difference. So now you can see that Social Security number and salary are both encrypted. And the reason why I cannot see that information anymore is my account, my login, doesn't have access to the keys. So this application is unable to decrypt the information that I want to see, which is the whole purpose of always encrypted. I'm a high privileged user. I can still do my day-to-day job, but I cannot see the data. So mission accomplished here. When I go back to my web application and I hit refresh, there you go. The application can still see that sensitive information. So you can still see Social Security number and the salary. Again, reason for that is this application has the appropriate permission on the key vault and on the key to do the encryption and the decryption of that sensitive information. And you can still search on it. So I'm searching on Social Security number now, which means that I can actually use that encrypted column in a where clause. So I'm basically under the covers, I'm using that enclave that is configured on my database. All right, to wrap up, what have we seen in this poster session? First of all, I've explained the motivation why we developed this functionality, always encrypted, because we wanted to allow our customers to store sensitive information in our cloud platform. Secondly, I've explained you more in detail how always encrypt actually works. And lastly, we have seen a demo that demonstrates how you can implement always encrypted on an Azure SQL database. Some resources that are available for always encrypted. We have a bunch of blog posts that's explaining the different functionalities. We have our official documentation. If you want to get started with always encrypted, I really recommend you go to the tutorials because that will show you step by step what you need to do to implement always encrypted. There is a YouTube channel called Data Exposed where there is an episode with me and Anna Hoffman explaining always encrypted. There is also a security podcast with an episode of always encrypted. And we also have some sample coding, like the application that I've used in the demo is available on GitHub. You can just freely download it and use it yourself. Thanks for watching. I hope you've learned something and enjoy the rest of the day.